Greetings everyone. Automation is good so long as you know exactly where to put the machine. Said by Eliyahu Goldratt, the Israeli management guru. Myself M. Jagadish of PSNA CET, representing my team, Tech Kids. Our idea of working on speed controlling device arose when we came across the increase in number of road accidents due to overspeeding. When we came across various speed governing devices, we noticed that most of them were working mechanically. So we were inspired to develop a device which governs the speed in an automated manner using image processing technique. The closest competitor to our idea is an ideal speed governor which controls the speed of the vehicle mechanically and a microprocessor based system which controls the speed using a sensing and electronic unit. The major difference is that these devices consist of a static speed limit which cannot be exceeded throughout their drive, whereas our device changes the speed limit depending upon the traffic signs available on the various areas and accident prone zones. Learning and observing various speed governing techniques used in current heavy load vehicles through practical approach led us to study more about the mechanism and develop a system which increases its efficiency by designing it in an automated manner. Limiting the top speed of a vehicle is usually done either through engine management systems or through a device which controls the throttle directly. Cruise control systems can also be classified as a kind of speed limiting system for vehicles which maintains a minimum speed but do not control the behavior of the driver, since they simply maintain whatever speed the driver sets them to. So, what is needed in the modern traffic environment is an automatic vehicle speed control system that will effectively influence driving speeds and prevent drivers from exceeding the speed limit, significantly increasing safety. The size of the device is slim and compact, which can be easily assembled in the vehicle. The power source of the device is the battery available in the vehicle, which acquires around 60 watts. Since IoT aid in making data collecting process easier and more dynamic, our system is an IoT ecosystem which consists of a USB camera and an embedded system, BeagleBone. BeagleBone collects and acts on the data it acquires from the environment. As BeagleBone Black has GPIO, a general purpose input-output, which is controllable by the user at runtime. It has high processing speed, which is useful in processing the images from the camera. Increasing the production of the device and installing it in numerous vehicles will raise the scalability. Since the device decreases the number of road accidents in a reasonable sum, the production of this device will be high. The TA component used in the device is BeagleBone Black. The GPIO and high processing speed in BeagleBone Black helps in developing the device more efficiently. USB camera is used to capture images which is sent to BeagleBone, where it is processed and is redirected to the mechanical component of the device, where the received information is used as an input to control the speed of the vehicle. The prototype has undergone the following verifications: software design verification, code verification, integration verification, system validation, and it also processes all the behavioral traits that the project prototype should have passed. The following is the technical milestones completed for product realization and implementation.
Initially, let me explain the circuit of this prototype. Providing power supply by using the 24-volt adapter to the solenoid valve and the 5-volt adapter to the BeagleBone reboots, and in the solenoid valve the current flows through it. The LED board present above the BeagleBone is an interlink between the solenoid valve and the BeagleBone. The LED board represents the basic functioning of the circuit. When the LED is on, the solenoid remains open, letting the vehicle to have a normal fuel flow. When the USB camera detects the speed limit signboard, the LED becomes off and it makes the solenoid valve to close, leading to stop the fuel flow for about 20 seconds. After providing current supply to the solenoid valve and the BeagleBone, the USB camera, which is connected to the BeagleBone, detects the speed limit signboard, which now in case is in the laptop, and it compares it with the speed of the vehicle, and if it exceeds the limit, the solenoid valve closes in order to stop the fuel injection. letting the vehicle to lower its speed. Here we can see after the USB camera has detected the signboard, the LED light has gone off, leading it to close the solenoid valve. After 20 seconds, which can be changed based on our convenience, the solenoid valve opens and it lets the vehicle to have a normal fuel flow.